Welcome back to Getting Started with Grasshopper. The main skill we need as Grasshopper users is the ability to understand the underlying logic of a design and to decode a design from its final appearance to all the small, intermediate steps that lead up to it. In other words, the ability to understand and create algorithms. This requires us to have a certain affinity to problem solving and critical thinking. The good news is that this skill can be applied to any other programming environment, and it can pave the way to coding and full-fledged programming down the line. We are going to get to know the algorithms most commonly used in architectural practice, and combine them with exercises designed to build your ability to think in algorithms step by step. So how do we approach a design problem in Grasshopper? The starting point for any Grasshopper script is an idea. What are we trying to create? What does our final output look like? We could have a particular image in mind. It could be a reference image or a conceptual sketch. Anything that will help us with the next step. Figuring out the logic of the design. The key question is, what are the key operations that will result in the desired output? That will lead to many further questions such as which geometries are involved, how are they generated, which parameters do we want to be able to change, and eventually which components are we going to use. Of course, this logic can and will change as we develop the script, but we need this logic to determine which components we're going to use and how we're going to tie them together in a sequence. Breaking down the final result into geometric steps can be challenging at the beginning. Here's a few ways that can help with figuring out the design logic. Putting it into words. It's helpful to describe the desired output in words. Can you describe it to someone else and get your idea across successfully? What questions do they have? Use their feedback to paint a clearer picture of your design. Articulating the image we have in mind helps us to make sense of it and break down the final image into a sequence of descriptive steps. Sketching. It also helps to sketch out the core geometric operations that will lead to the geometry we have in mind. We should try to be as specific as possible. What is our starting point? How high are the elements? Do they have different heights? If they do, what drives the height? Which way are they oriented? What defines the extrusion direction? We should already think in as much detail as we can. We can also try and think backwards. Sometimes it makes sense to think backwards from the final result and ask the question, what do we need as a basis for the last operation? For example, an extrusion. And repeat the question over and over again until the design is decoded. For the most part, the geometric steps will be the same we would use when modeling in Rhino. But there's one major difference. While we can directly select particular objects in Rhino, in Grasshopper we'll need to express our selection in a relative way. For example, the second item in a list, or the surface facing up, or the longest of a set of curves, or the object closest to a point. Describing object selection this way means that our script will not just work for one particular input, but for any similar input, and even multiple inputs at once. Once we have a clear design output in mind and we have a rough roadmap of how to get there, that's when we open Grasshopper and break down the logic into component sequences. We'll find the components that can best recreate the logic we sketched out and flesh out the script from there. This is where we're going to apply the programming concepts, use specific components, and manage the data flow. Any design in Grasshopper will only be successful when all three of these conditions are met. We need a great design idea, a clear logic of how to build it, and the ability to convert the logic into components in Grasshopper and handle the data along the way. If we lack a clear design input, Grasshopper alone will not generate a great result for us. If we don't figure out the logic, we won't know which components to use. And if we don't have a strong command of the data flows in our scripts, we will run into trouble when putting together the script. Each design exercise in this training will follow these three steps. We will define a design goal, break down the logic into a sequence of simple steps, and then learn how to convert it into Grasshopper components. Tomorrow we'll build our first full Grasshopper script. I'll see you there.